Hi, in this video we are going to talk about water. You all know that water is one of the most important biomolecules in our bodies, since it constitutes 70% of our bodies. The oxygen atom in the water molecule is bonded to two hydrogen atoms, and have two pairs of unbonded electrons. This makes the oxygen atom looks like the carbon atom with sp3 hybrid orbitals in its tetrahedral shape. 109.5 is the ideal angle in a tetrahedron. Although the angle between hydrogen atoms in the water molecule is 104.5, this is due to the crowdness of unbonded electrons orbitals. The electrons of the hydrogen atoms are somehow attracted to the oxygen nucleus. This is due to the higher electronegativity of oxygen atoms. The unequal distribution of the electrons results in a partially negative charge on the oxygen atom and partially positive charges on the hydrogen atoms. Water molecule can therefore form bonds with other neighboring water molecules. These bonds are called hydrogen bonds. Not only water molecules can form hydrogen bonds, other molecules having an electronegative atom such as nitrogen or oxygen can form also hydrogen bonds, but not carbon because the difference in electronegativity between carbon and hydrogen is not that big. Water molecules can form hydrogen bonds also with other compounds capable of doing so, such as alcohols and aldehydes. One more thing to know about hydrogen bond is it's 10% like covalent bonds due to the overlapping of the orbitals, and 90% electrostatic attraction. As you saw previously, that one water molecule can form 4 hydrogen bonds with other 4 water molecules. Actually, this occurs only when water is in the solid state, while in the liquid state, due to continuous motion of water molecules, one water molecule can form hydrogen bonds with an average of 3.5 water molecules. You should also know that hydrogen bonds are weaker than covalent bonds, and the difference is really big. As we can see that we need only 23 kilojoules per mole to break a hydrogen bond, while to break the covalent bond between oxygen and hydrogen we need 470 kilojoules per mole. Okay, here are some of the properties of water that are affected by hydrogen bonds: boiling point, viscosity, and surface tension. Let's see an example concerning boiling point, but on another compound other than water. Here we have butane, an alkane with 4 carbon atoms. This compound has a boiling point of minus 0.5 Celsius. If a hydroxyl group was added to this compound to form an alcohol, which is in this case will be butanol, the boiling point will be 117 Celsius. This is because butanol molecules now have a new type of bonding that keeps them tight with each other. One last thing I want you to know is when the 3 atoms involved in a hydrogen bond lie on a straight line, the bond will be in its strongest form, while if there is any constraint on the bond that makes it bent, will make it weaker. Okay, now let's talk about water as a solvent. If you ask yourself how does water molecule dissolve polar compounds such as alcohols, amines, or aldehydes, the answer will be simply by forming hydrogen bonds with these compounds or solutes. So how does water dissolve a charged solute such as sodium chloride, which has atoms strongly tied together by ionic bonds? Water molecules hydrate these ions and stabilize the charges on it, in which a partially negative oxygen will face the positive sodium ions, and the partially positive hydrogen atoms will face the negative chloride ions. Let me tell you a small story. There was a French physicist called Coulomb, who is well known for developing, of course, Coulomb's law. He studied the force of attraction between charged bodies. Q1 stands for the charge of the first particle, and of course Q2 for the second one. R represents the distance between these two charges, and finally F is the force between them. It is obvious that if the charges are large, the force will be large, and if the distance is great, the force will be small. If the charges are both positive or both negative, the result will be positive, which means that there will be repulsion between the particles. But if one is positive and the other is negative, the result will be negative, which means attraction. So what does this all have to do with water? In order to see the effect of a solvent on the force between the particles of a solute, we'll have to introduce one of its properties in this equation, which is the dielectric constant. Water, for example, has a dielectric constant that equals 78.5, while another solvent like benzene has a dielectric constant that equals 4.6 only. If a solvent has a large dielectric constant, the force between the particles of the solute will be small, and vice versa. So what would be the case if we added a nonpolar or hydrophobic solute into water? If we had the solute particles separated alone as we see here, this will mean that the surrounding water molecules will be stressed because they are not free to be in any conformation they want to, as the water and the solute molecules hate each other. This means that they are in an ordered form or state. Actually, what happens is that the molecules of nonpolar solutes stick to each other to reduce their surface area, so that the number of the surrounding water molecules which are in order would be lower. Well, forgive me for this stupid drawing. What I meant is, by decreasing the surface area of the solute, 6 water molecules instead of 8 will be surrounding the nonpolar solute. Well, all of us prefer to live his or her life as his minds tell him, without following any instructions from others or undergoing any discipline. The same goes here with the molecules, which prefer to stay disordered so they'd be more stable. Entropy is the scientific term for disorder. In thermodynamics, we'll see that any system will be more stable when it has a lower energy level. This is represented here by delta G. The more the negative is the delta G, the more stable the system is. Don't bother yourself with delta H. It will be discussed later in thermodynamics. Delta S is the entropy, and as the disorder or the entropy increases, the delta G decreases, the more favorable is the situation. Thanks for watching, and please feel free to post a comment or ask a question.